Welcome to another video about MWD technology. In this video, we are reviewing the current technology in the market. Also, we are talking about some development in MWD space in the year 2022. Summary of what we are going to talk about in this video. First, we are talking about floating single shot, which is a development in single shot space. Then we are talking about main MWD modules, our power, telemetry, and directional unit. Then MWD classifications and Gyro MWD. Also, we are talking about magnetic ranging MWD and a simplified MWD string, which is developed by a company in Canada. Over the years, surveying technology is developed from single shot surveying tools, which cost about $600 to MWD kits currently in the market, ranging from $600,000 and more. Single shot surveying tools were giving us inclination only. They had a mechanical watch and a paper chart. The paper chart was leading us from 0 to 10-12 degrees. We use this tool to read the well inclination for shallow holes up to 500 meter. And how we used to run them was to put a seat called Totco seat on top of the BHA and run with the wire line. Wait for the clock to fire and punch a hole in this chart. And then we pull out of hole with the wire line and read the inclination of the well. A company in single shot space has developed this tool, which is a self-floating single shot. It is able to read not only inclination but azimuth also in deeper holes up to 2000 meters. It has sinker bar, buoyancy tube, and an electronic watch. The pros of this tool is that it doesn't need a wire line to run. It doesn't take much of the operation time on rig. The drawbacks of this tool is that adjusting clock to fire at a specific depth is tricky. Plus, it needs a high quality seat not to be washed in heavy mud. Operating this tool is pretty simple because you pump it down at the end of the section when you do the bottoms up, and it just goes down, seats and read. And when you turn the pump off, it just self-floats back to surface. This section gives you a mental image about MWD main modules, and we are going to briefly talk about each modules, how many types they have, and what are the pros and cons on each module. Power module is one of the main modules, as we talked about, and it gives the power to all the components to collect the data and send it to surface. So the very first and easiest one is the battery. Battery is a power source that provides direct current or DC. The problem with the battery is that it has limited hours, and for long wells and ERD wells we cannot use a battery. Another downside of the batteries are that batteries are not able to withstand the high temperature and high pressure environment like deep wells, because these battery cells will explode in very high temperature. So for that reason, the manufacturers have developed turbine alternator, which is like your car, and it just with the flow of the mud passing over the beam pillars of turbine, it produces power and gives it to alternator, and it changes AC or alternative current to direct current, and the direct current feeds the component of MWD. Turbine alternator usually comes in two settings. Either they are standalone, as is depicted here, or coupled with pulsar. And the very new types of a power module is the combo of both, means battery and turbine, and the battery usually is backup for the system. Turbine usually provides the power for the string, and whenever we are not pumping and the turbine is not working and no power, battery comes in, kicks in, and provides power for all the string and all its component. The power module is a small section in the BHA, and the turbine alternator types, which is coupled with mud pulse, and this is the same. So when mud is passing over the pulsar and it goes through turbine, and turbine generates power and feeds it to alternator. Alternator changes it to direct current, and it feeds all the other components. In this session, I'm going to explain a measurement while drilling tool, or MWD string, which uses a pulse. We have three pulse tools. Like one were old technology, which was called negative pulse. So what negative pulse is basically you are making a sudden vacuum in your drill string or BHA. There is a port which jets out part of the mud based on the time and generates a vacuum inside the drill string, and that vacuum sensed by the surface transducers, and that's interpreted as the pulse coming the surface and decoded in the MWD laptops or MWD surface system, and gives you the data about the well direction and inclination. So a generation after that is positive pulse. Pulse is like it simulates to a hose, like a water hose. So as you put your thumb on the end of the hose, it gives you a back pulse, and then back pulse, if you do it repeatedly, it gives you a back hammering effect of that water, which is sensed at the end of, say, tap. So that tap is our sensor on the surface, and those pulses are generated by 2-3 mechanisms, which is common in the oil field. And one of them is a poppet orifice, which is a poppet going in the orifice, restricting the mud flow and making that pulse. The second is a impeller system, like kind of like a impeller, which is going 1 and 0 and 1 and 0 and 1 based on the time program in the tool memory, and it opens and or closes or restricts, not closes, it restricts the mud flow. The third type is also another impeller system, but it does it like 360 degrees, not on and off, close and open. It just goes 360 degrees. So these are the like different categories of the mud pulse system. Old technology, new technologies now having something called electromagnetic, which doesn't care about the mud pulse, doesn't have to do anything with the mud, and it just propagates electromagnetic waves into the formation, into the ground, and then detects at some antenna. Here I would like to talk more about electromagnetic MWD, because I feel it's not talked about enough, and there are not very good resources on internet, and I didn't find any good videos. I'm having another MWD in-depth video regarding its function, its test, how you run it, how the tool looks like, and its functionality, and all other details, which are coming shortly after this video on my channel. So electromagnetic MWD's principle is conventionally used for finding water, and the principle was that they used two electrodes to send a direct current to the ground and measure the voltages with this machine, with the voltmeter, on the other electrodes or other probes or stakes or whatever you want to call them, and they would measure the resistivity by this formula. So they had the current run on, and then had the they could measure the voltage, and they come to know the resistivity, and from the resistivity they would think what kind of soil is down there, and if the resistivity was low, it means good conductivity and means some water in the formation. So the same principle used for electromagnetic MWDs, except they changed the DC current, which was like batteries, to AC current. With this AC current through these subs and gap subs inducts electromagnetic waves in the formation, and then we measure at surface with our antennas, and we measure the voltages propagated from MWD tool. So, and then By a technology called frequency shift keying, they convert these voltages to frequencies, and because AC current has frequency, and they change this AC current to frequencies, and by decoding those frequencies to zeros and ones, then they decode those zeros and ones, which are binary numbers, to regular numbers, and they calculate inclination, azimuth, tool face, and etc. Tandem BHA or Tandem MWD is a concept that we put two strings of different kind of MWD together. Imagine if we are drilling, this is the well direction, and we are drilling this way, we could use a power section, a directional sensor, and a telemetry section, in which we are using accelerometer and magnetometer, as in a regular magnetic directional unit. And for telemetry section, we use a pulse tool with a higher frequency. Upper in the BHA, in a non-magnetic drill color, we use a directional gyro unit plus another pulse tool, but with lower frequency. So for this setup, we use two transducers. One of the transducers decodes the higher frequency, and the other decodes the lower frequency. And in this way, we can decode and take surveys simultaneously. And also, it is good to know that magnetic directional unit is taking a lower time for survey than gyro directional unit. Directional module of the MWD system, which also called directional unit, is the brain of the MWD string. Unlike pulsar, which is the hard pulsar, or the transmission part, which is the heart of the system, the directional unit is the brain, and it collects the information. It measures the inclination and azimuth, and it gives it to pulsar or transmitter to send it to surface for us. Non-magnetic directional unit, which is also known as gyro directional unit, it utilizes a gyroscope and one accelerometer, and it is measuring the mass and spin of the earth. Hence, it is just looking for true north rather than magnetic north. The other types of directional unit highly utilized in MWD strings are magnetic ones, and the drawbacks with this one are affected by magnetic interferences. Magnetic interference can be from environment, from the drill string, from casings, from any fish in the hole, or from the earth itself. So these are the ones that are looking and finding the magnetic south and magnetic north of the earth, and by using a set of accelerometer and magnetometers, they are measuring the inclination and azimuth. There are many resources for magnetic directional units on the internet, and here I'm not going to talk about it. I'm focusing on gyros. Two companies in the space who have developed gyro are GyroData and Scientific Drilling. They are pioneers in this space, in this technology. What is presented by Scientific Drilling is a tandem Tandem MWD string, which they're utilizing a gyro directional unit plus a specific gyro battery, and they have also utilized a magnetic directional package plus MWD battery for everything else. They're utilizing a pulsar to transmit data to the surface. The drawback and limitation of Scientific Drilling tool is that it is operatable to maximum inclination of 40 degrees, and beyond that it is not working properly. And there is a limitation with this gyro battery, and it is only working for 50 hours, and beyond that you have to pull out a hole to change this gyro package battery. GyroData, on the other hand, their tool is working up to 90-degree inclination, and I have to dig deeper about their technology, because their gyroscope, which is reading earth spin at 90 degree, is going to be very interesting. I haven't had much of information about GyroData and how they do it, but I know that their tool is working to the gyro tool is working to 90-degree inclination. And here, as you see, they have a gyro, electronics, and 2 batteries. Probably that's why their tool is working and designed for the deeper holes. Gyro is a good piece of technology because, and it has interesting facts. Like when you talk about gyro MWD, gyro itself, you have to know is a directional unit only, and gyroscope itself acts like an accelerometer rather than a magnetometer. So because it's looking at the mass and spin of the earth, so you can assume that you have the 2 accelerometer sensor in your directional unit. And for that reason, it is not affected by magnetic and no magnetic correction or magnetic declination. When you calculate your survey conventionally with the magnetic package, you don't need to correct for that magnetic declination. Gyro directly reads true north. Also, gyro is very sensitive to movement, so while the pump's on, you cannot take survey with the gyro. Unlike conventional directional unit, which has magnetometer and accelerometer, you can take survey with electromagnetic tool or pulse tool while the pump's on. MWDs have 2 types of mounts. One of them are the probe-based mounts, and the other is color-based. The good thing about probe-based are that they are retrievable, means they are fishable. In case your string is stuck, you still can pull out your MWD string and save a lot of costs of operation for client. But the drawbacks are they have a higher vibration. So in the shallow holes and in big holes, which they have a lot of jumping and a lot of beat bouncing and vibration in the string, you might have more problem with probe-based MWD rather than a color-based MWD. They are also hard to run because every time you have to disassemble them, assemble them back, a program, and check a lot of connections and components, electrical and mechanical connection, for this probe-based MWD to work. But color-based MWDs, on the other hand, they are not retrievable. So because this is a piece of steel with just a non-magnetic color, goes down deep in the formation, and if it's stuck, you cannot run fishing tools to retrieve it back to surface. But they are robust, and they making less noise and less problem due to vibration. And also they are easy to run because a piece of pipe coming from the shop, all you have to do is to program it on location based on your qualifiers, and make these connections to other LWDs or any other tools that you have, mechanical connection, and that's it. You run it, and that's easy. So from mount point of view, probe-based MWDs are also divided in 2 categories. The one with fixed mount, your pulsar and your string are fixed in the BHA. They are locked in with some tie screws, so you cannot fish them. And there is the retrievable pulsar and or retrievable string, which you can, even after stock, you just can run your fishing tool, latch onto this spare point, and pull it out of hole. Based on what is discussed so far, if you are presented with a tool or see a tool's brochure, you can now judge and comment about that tool's functionality. For instance, this tool is a Schlumberger MWD, they call it Telescope. And by looking at this tool, you can see that its power module is generator alternator coupling right here, and then it is a battery-less MWD, and so now we know it's good for high temperature operation or deep drilling. You don't need to pull out for battery. The transmission module, which is the heart of the system, is the impeller, and it's a continuous impeller. We said that the pulsar is the heart of the MWD system, and the DNI or directional module and electric module is the brain of the system. By looking at the brain of the system, which is all the electronic module and the directional unit module, you can say this is a magnetic MWD, and is equipped with other sensor for shocks and vibration and gamma ray. The concept of modular versus non-modular MWD is that companies mix and match their MWD strings component to make a whole new tool. So for instance, here we have a pulse MWD string which has two batteries, directional unit, gamma, and a pulsar. Companies like APS and Tensor is providing this set of MWD string. So being modular means if you can change the components order and you build a new tool with the same component, but the order is different, and you can create another MWD string, which say for instance electromagnetic MWD here. The only thing is different is the transmitter between these tools. So we have just EM electromagnetic transmitter versus a pulsar, which is the heart of the system. Everything else, like the brain of the system and the power section, remains the same. First time I heard about Ranging MWD and my colleague was talking about it, I thought the Ranging MWD is a whole new tool and something which is manufactured differently than other MWDs. When I read about it, I came to know the Ranging MWD is more of an operation than a new tool. Currently, there are two types of Ranging MWD operation in the market, and the companies are marketing it as such. Magnetic Ranging MWD operation, the concept is around MWD, what kind of MWD you're running and what is your excitation method. This is a magnetic excitation tool that you are using, plus your conventional MWD systems, which is usually electromagnetic MWD. This method is used for drilling steam assisted gravity drainage wells, relief wells, anti-collision, and so on and so forth, and similar operation when you want to drill close to a offset well. So the first concept is to use in your drilling well or in a subject well, you use electromagnetic MWD plus a special sub, and in your offset well or object well, or you run wire line plus a magnetic coil. So here I'm running a wire line and a magnetic coil in this well, and I run my sub and MWD in this drilling well. Whenever I want to take survey, I excite my coil and I take a survey here, and I know my direction and distance from this offset well. The second concept is to run an electromagnetic MWD plus a sub in your subject well or drilling well, and in your object well you don't run any wire line, and this is a good part. You don't run a wire line operation. We don't have a wire line operation. You don't have those risks involved, and you just excite your casing and make it like a magnetic casing, and when you take this survey, you know that your distance and direction from the offset well. Halliburton has this ranging tool which they call it WellSpot. It's their wire line ranging tool. As we talked about, there is a coil or sensor package in this offset well, and then they excite that coil and they may take the measurement with this MWD, which has a magnetic resonance, sub, and then you know your distance and direction from this one. The other tool that Halliburton has is the sub that they are using with their MWD string. This is a surface setup for Halliburton surface excitation method. So what they do, they just use these wires to hook up to the offset well's casing, and whenever they want to take a survey while drilling, they excite the surface casing and they take a survey, and they know their direction and distance from this offset well. The next change in MWD space is done by a Canadian directional company that he has simplified and shortened the MWD pulse MWD string, and they call it direct drive MWD. So what they have done, they have eliminated bottom end and shock absorber from the pulse string, and like top landing tools, there is no need for shock absorber or what they say, and they have directly connected this pulsar to the mule shoe. So you run the tool, you hang it off in your hang off sub, or you landed here in the mule shoe, and there is no need for a shock absorber and bottom end. The other requirement is that for every collar size you need a special hang-off sub and mule shoe.